So today we're gonna just have a lot of more practice with these systems because I felt like we need more practice with more variable system. On a discussion board, we practice with two variables and two equations, but we're gonna be working mainly with several variables. If I give you three variables, if I give you four systems, five variables, etc. So this is a assignment that I gave to my other class over here, but I want to show you guys how to work it out just in case. So we have these two systems right here, omega and lambda. Let's work with omega first. We want to find the solution to omega. In particular, I can write my system out. Let's just write it out. This is too large. Fix that up. X minus 2y plus z equals 1. Y plus 2z equals 5. X plus y plus 3z equals 8. This is omega. Now, we have to treat it with multivariables, so I need to turn this into triangular form. So if we observe the first row, that's good. The reason why it's good is because our first variable is x, and that's what we have. Boom. That's already nice. And the leading coefficient of x is 1, so that's also a good thing. If I look at my second row, well, that leads with y. That's perfect. Y is my second variable, so I should lead with that. And the leading coefficient is 1, so I'm also good with that. The third row, however, I have an x and I have a y that I need to get rid of. Now, I need to get rid of them completely, which means I need to add it by a negative x somehow. The only way I can add it by negative x is if I multiply the first equation or first row by negative row 1 plus row 2, and of course I'm going to send it to row 3. In doing so, I will have nothing changes in the first row. This is still the exact same. I encourage you to do scratch work as well, but you should have, if I add the negative versions of it, so the x's are gone now. Now negative 1 times negative 2y, that's positive 2y, so I get 3y. But the x term is deleted, so that is nice. I already got one term deleted. And then negative 1 times z, that's negative z, so I get plus 2z equals the negative 1 times, or 1 times negative 1 is negative 1 plus 8. That's going to give me 7. Now with this system in particular, I need to get rid of this entire guy. Some of you guys might say divide by 3, but remember, I need to get rid of the y completely. I can't just divide or scale the third equation by 3 because I would still have a y as a variable. I need to get rid of the variable completely. So what I need to do is multiply the second row by negative 3 and add it to the third row. If you need to delete a variable, you do need to add. If you need to turn the variable or to change the coefficient to 1, then you can scale it down. So now my new equation becomes, this is again too large, but now I have x minus 2y plus z equals 1, y plus 2z equals 5. And then if I actually multiply that by negative 3, the y's are deleted. Negative 3z, or negative 3 times 2z, that's negative 6z. So this becomes negative 4z. And then negative 3, so that's negative 15. Negative 15 plus 7, that is negative 8. Boom. And I'm going to do it over here. So my third equation almost looks good, but I need to get rid of this negative 4. And I need to get rid of it by scaling it downwards. I do not want to delete the z. I like it where it's at, so I'm not going to add with any equation. I'm just going to scale it down. So now I have x, and I'm going to in particular do negative 1 over 4 of row 3. X minus 2y plus z equals 1. Then I have y plus 2z equals 5. And then I have z is equal to 2. Boom. So we're looking good now. Now all that's left is remaining is to solve the system. Well, I have z equals 2. If I were to substitute that in, over here I have y plus 2 times 2 equals 5. which this is going to give me y plus 4 equals 5. So this is going to give me y is equal to 1, z is equal to 2, and then we just got to calculate x now. If I see x, x minus 2 times my y value, which is 1, plus 2, which is z equals 1. This is going to give me x equals 1. So now my solution, you always write the x first. It's going to be 1, 1, 2. Boom. This is my solution. It's exactly one solution, but I have a tripled pair, or an ordered triple, I'm sorry. Ordered triple. That's the solution for omega. Oops. Now let's go with lambda over here. These are just names, by the way, so do not get confused with the symbols. They're just names. So now I have negative 3x minus 5y plus 36z equals 10. Negative x plus 7z. I put some spacing there just to make sure we don't make any mistakes. But, you know, on tests and everything, there might not be these spacings, so you need to know where they belong at. Oh, the 7 and the z are going to confuse me. Let me fix that up. There we go. So looking at this, we can look at the first row. The first row, it's already bad because I have a negative 3 over here. I need to have a coefficient of 1. Now, there's multiple ways to approach this. You can scale it down by negative 1/3, or an easier way is to swap row 1 with row 3. Why am I swapping? If you notice, this guy has a coefficient of 1. So I actually like that a lot. So I'm going to swap it because it's much more simple. If I swap the rows, my new equation or my new system becomes x plus y minus 10z equals negative 4. Second row didn't change at all. Equals 5. And then we have negative 3x minus 5y plus 36z equals 10. So the first row, it's good. We start off with x and we have a coefficient of 1. I like that a lot. The second row now, however, I have an x. I need to get rid of that completely. So I'm going to get rid of it. And the way you get rid of a term, you have to add it with an equation. So I'm going to add row 1 plus row 2, and I'm going to send that to row 2. So if I add these together, row 1 does not change. I have x plus y minus 10z equals negative 4. Then I have the x's cancel out. I gain a y out of that. And then I get a minus 3z equals 1. So I gained a y just because I was able to add it. So that's nice. Negative 3x minus 5y plus 36z equals 10. Boom. Now, the first row is good. It has a coefficient of 1, and it starts off with x. Second row is good. Coefficient of 1 starts off with y. I'm already happy. Third row, however, has this and this guy. Let's first, and a general rule is to get rid of the first term. So we're going to get rid of the negative 3x. And the way I get rid of things, I have to add. So in particular, I'm going to do negative, or not negative, sorry, positive 3 of row 1 plus row 3. I'm going to send it to row 3. In doing so, I have x plus y minus 10z equals negative 4. This still stays the same. And I encourage you to show your scratch work too. I'm not going to show with the interest of time. But now if I do negative 3 of that, all of that, that's going to be 0 for the x term. So my x terms are gone. 3 times y, that's 3y. So I'm left with minus 2y. And then 3 times negative 10z, that's negative 30z, plus 36z, which is 6z. And then this is equal to, now, 3 times negative 4, that's negative 12, plus 10, that's negative 2. We're almost there. Now I got to get rid of this right here. Actually, no, I'm sorry. This is the third row, so I need to get rid of the y term completely. So again, I have to add, in particular, 2 times row 2 plus row 3. So I'm not dividing by 1/2. Otherwise, I do not delete the y. So now I have x plus y minus 10z equals -4. Y minus 3z equals 1. And then if I multiply that by 2, this becomes zeroed out, so there's no more y's. 2 times -3, that's -6, so this becomes 0 equals 0. And in this case right here, this is our x row. So this is, we have an x, we have a y over here, but I don't have z solved out. So this means that z is a free variable. These sizes are getting to me. Z is a free variable, so I'm going to call that z to be t. This is a free variable. Z is free. Now, if I write my solution, I get y minus 3 times t equals 1, which this is going to give me, if I solve this out, y is equal to 1 plus 3t. Z is equal to t again. Remember that? Don't forget that. And now I got to solve for x. X plus y, which is 1 plus 3t minus 10 times t equals -4. This is going to give me, if I add those together, x is equal to, what is that? Minus 7t plus 1 equals -4. So this is going to give me x is equal to -7t minus 5. Y is equal to 1 plus 3t, and then z is equal to t. So my solution to lambda, lambda solution is going to be -7t minus 5, comma 1 plus 3t, comma t. This is my coordinate location. So this is a problem with infinite amount of solutions. This one has exactly 1. This has infinite amount. Now, for more practice, I want to make sure that we also cover different cases that can happen. So let's do 2 more problems, and then we'll move on to the next subject. So the next 2 problems I want to work with, let's see if I have them with me right now. I should have them. This is a good one. Let's work with this. Special cases. These aren't really special cases. Because students think they're special. So I write that down. They're not really special cases at all. But let's do another one. I'm gonna call this letter A, or the system called A. Plus 2y 2z equals 1, and I'm gonna have 2x plus 2y minus z equals 6, and then 3x plus 4y minus 3z equals 5. This system right here. First row is good. Second row, I need to delete the x. So what I'm going to do here is I'm going to multiply that second row by negative, or the first row by -2, row 1. And I'm going to add it to row 2. And I'm going to send it to row 2, of course. That's going to give me x plus 2y. Nothing happens with the first row. The second row, 2 times 2y, that's 4y plus that. That's going to be 6y. Oh, no, I'm doing -2, I'm sorry. So if I do -2 of that, -4y, 4y, so that's -2y. And then -2 times -2, that's +4, so that's plus 3z equals -2 times +1, that's -2, so that's going to be +4. And in the last row, So I'm going to scale it by 1/2, -1/2 of row 2. I encourage you guys to think of multiplying instead of dividing and adding instead of subtracting because it can get very messy later on. Minus 3/2 z equals -2. Then I have 3x plus 4y minus 3z equals 5. And then I need to get rid of this x term. This is good. This is good. This x term I don't like. So I'm going to get rid of that. I'm going to add -3 of row 1 plus row 3, send that to row 3. So in doing so, I will have x z equals -2. Then a third row, multiplying this by -6y, -6y plus 4y, that is going to be -2y, and then -3 times -2, that's positive 6z, so this becomes positive 3z equals -3 times 1, which is -3 plus 5, that's going to become 2. I need to get rid of the y term now, so I have to add, which means I have to do negative, or actually not even negative, I can do positive. I can do 2 times r2 plus r3. I'm going to send it to r3. If I do that, I get x plus 2y minus 2z equals 1. Y minus 3/2 z equals -2. And then I have, now I can actually start canceling out. Well, if I add these together, this becomes, well, this is zeroed out. Good. The y's are zeroed out. The z is also zeroed out, thankfully. And the last term, however, 2 times -2, which is -4. So I get -2. And why do I say this is a weird special case? It's not really a special case, but students find it. It's because I have this right here. 0 equals -2. That's a problem. We say that this system, A, has no solution. Remember, A is the name of our system. We called it A, right? So just because I wrote A equals whatever, or A is, there's no solution for A, don't always write that down. It depends on what system you have. So I wrote A over here. Some students like to parrot everything I write, which they don't understand the meaning, so that can cause problems. But A has no solution. I want to do one more special case, and then that'll be the end of this video, and I'll post another one shortly. But the next one I want to do, particularly to give you guys insights, is, let's see if I have it. Let's do blue. Let's call this B equals 2x plus y minus 2z equals 12. Negative x minus 1/2 y plus z equals -6. 3x plus 3/2 y minus 3z, oops, this is be a z, equals 18. Already looking at this system, it doesn't even look nice. So what I'm going to do here is, there's multiple ways to approach it. I'm going to in particular do 1/2 of R1. If I do that, I get x plus 1/2 y minus z equals 6. Everything else stays the same. And then I'm hoping you guys see something that happened. If you noticed, the first two equations, they're just negatives and positives of each other. So I'm going to now go kind of out of order because I want to delete the x. I want to delete the, actually, let's just delete the x. I'm going to add them together. Row 1 plus row 2. And I'm going to send that to row 2. In doing so, I will have x plus 1/2 y minus z equals 6. Now if I add these together, I get 0. The x's are canceled out. The y's are also canceled out. The z's are actually canceled out. So I get 0 equals 0. And I get 3x plus 3 halves y minus 3z equals 18. Now, I am a fan of having this at the very bottom. So let's move that to the very bottom. This is good practice. So we're going to swap row 2 with row 3. If I swap the row 2 with row 3, I have x plus 1 half y minus z equals 6. 3x plus 3 halves y minus 3z equals 18. And I have 0 equals 0. Now, if I want to get rid of the x term, I have to multiply that by negative 3, because this guy right here has to be deleted. So I'm going to multiply that by the first one by negative 3, the first row. I'm going to add that with the second row, and I'm going to send that to the second row. So if I do that, I have, let's see, 1 half y minus z equals 6. And I'm multiplying by 3. The x's are canceled out. Negative 3 times 1 half, that's negative 3 halves. So the y is also canceled out. Well, negative 3 times negative z is positive 3z, which that also cancels out. And negative 3 times 6 is negative 18, which cancels out too. So I get 0 equals 0, 0 equals 0. Students find this a weird case, but I really don't. But the thing about it is that the last line represents your z. The second equation represents your y. So we say z is free and y is free. But are they the same values? I can say z is free. Let's call it t. But does the y value have to be the same? No, it does not. The y can be different. It is a free variable, but they can be different. So I'm going to assign y to be a different variable. Let's use s. We use s and t's because in physics they use it all the time for time and seconds, of course, or times whatever s they represent that as. And then if I plug this in, so for x plus 1 half s minus t equals 6, which means that I have x is equal to, what is that? Negative 1 half s plus t plus 6. Y is equal to s, z is equal to t. So my coordinates is going to be solution to t is negative 1 half s plus t plus 6 comma s comma t. That is my solution. Now, for this to make sense, you want to think of it as x will depend on whatever the y value is and whatever the z value is. So if I have a solution, my solution is infinite amount of solution. I have infinite amount, but the coordinates of those solutions are going to depend on the x position, the x-axis is going to depend on the y term and the z term. Your y and your z do not necessarily have to interact with each other, but they are going to be different parameters. We have two different parameters, two different free variables. And this is how you express your solution possible. All right, so that's another example of an infinite amount of solution that you guys might be dealing with for the final exam. And I'll leave it at the end of that. I think this is a good stopping point. But the next video will be about matrices and how to actually use them. So I will catch you guys later. Take care. Bye.